Good morning, everyone. Welcome to October. Yes, my favorite month. I know some people don't like it. It's okay, though. All right, so let's go ahead and look at our content. It's actually just kind of a public service announcement for all of us. We are halfway through our trimester 1, and so we have 3 projects under our belt so far, but we do want you to go to your grades tab, check your grade for the Unit 1 and Unit 2 projects if you have not completed that, or if you do not get a passing grade on both projects, you need to sign up for a tutoring slot. We have some tutoring slots, doodle.com. Those are to help you with your projects, to get you through. Sign up for one of them. Again, let me tell you that me and Mrs. Larkin are one and the same, so we want you to sign up for the best time slot. You do not have to sign up for the teacher that you have on record. It's just simply find a good spot, a time for you, and then you can get into that spot and join us for a tutoring session. It doesn't matter who you go with. All right, with that being said, let's go ahead and go over our social question. It kind of leads into our project today, and we're going to do something a little different, so hold on tight, and we will show you that in just a moment. Are you artistic or musical? Elaborate if you don't really have practice either. What type of music art do you like? I'm saying we have a lot of artists, and I love it. I love to type of art. I love any type of art. Brisa, I'm not a huge fan of art, but I like music, which is still arty. Artsy there, Antoine. I don't know why I just said Antoine. Artistic, I do photography. That is awesome. Caitlin, beautiful. I like most music except for country music and heavy metal. I also love art. That's awesome, Sally. I can't draw and I don't like music. That's okay, Andres. You know, sometimes that fine arts is not for all of us. No, I did not, Antoine. I don't know why I said that. I have too many things going on in my brain right now, and I just mixed whatever was in my brain and then saying your name together. It was crazy. Crazy moment there in my brain. But, and Andres, it's absolutely okay. Sometimes we're not into art or the fine arts, we could say, but that's okay. We appreciate that anyway. Both Ivana, awesome. Yes, I do. I totally have a bad habit of thinking faster than I can talk. Most definitely. All right, here we go. So today, remember, our Class Connect sessions are recorded and distributed for learning purposes. Please do not share any personal information of yours or others into the chat box for your protection and the protection of others. Please be respectful and always, often and well. I don't know why I just did that. So here we go. Remember, we are halfway through our adventure together on trimester 1, 31 days out of our 60. It is Friday, October 2nd. TGIS. Topics are properties of waves today, and then we're going to actually do something new, so hold on tight. We are not going to do an in-class assignment, but we're going to be doing our project and working on our project slides in class. So instead of doing in-class assignments, we're going to make our lives a little easier. We're going to try something new. We think that it's going to be awesome, and working on our project in class right here with you is going to be so much easier by time at the end when we have to turn in our project. You'll be like, done, here you go. So let's go ahead and talk about that right now. Actually, before we do that, we're going to talk about our unit. So remember, we are moving into Unit 3, which is waves. So we're going to talk about, actually it's Unit 4. I just realized it's Unit 4. Properties of waves and all the different types of waves, sound waves, electromagnetic, and light reflection or refraction. So yes, thank you. Thank you. And I just realized it on period 3 that it was Unit 4. Mrs. Larkin, did you notice that, or is it just me? All right. So today we're going to compare and contrast mechanical and electromagnetic waves. Oh, we're a hot mess, absolutely. It's Friday, that's the problem. Identify the different types of mechanical waves, and then and what we're going to also talk about is the definitions of the properties of waves, like crest, trough, wavelength, and amplitude. So those all are important things to be knowing about. And we're going to be working on slides 7 and 8 of our project today, so a little different. So I want you to go ahead and instead of doing, no longer doing our class assignments, we're going to be doing our project slides in class. So we're going to just send out those links. So right now we just sent out those links, so go ahead and start opening that up. When you open that up, you're going to see something like this, and I'm going to go ahead and screen share this with you really fast. Alrighty, so you should see something like this on your screen. Once you have that opened, you're going to make a copy. Once you make that copy, then you should see something like this pop up. This beautiful slide with this pink and orange and all sorts of good stuff here. Folks, I do want to remind you that anytime you do work on this, Google Drive automatically saves it. So I've seen a lot of times where people panic, oh my goodness, I just lost all my slides. You have it there. It's in Google Drive, just to let you know, and you are that aware. As long as you make that copy, as long as you open it up, you're good to go. All right, with that, let's go ahead and get those green checks for those who have opened up your Google Slides. If you are having trouble, communicate with us. Give us a red X. Let us know what's going on. If your computer is lagging, whatever it may be. The best bet, too, is if you want to work on this a little bit later, take screenshots, take pictures, whatever you need to do, but make sure you give us a green check saying that I am ready to go. Luis, do you have an issue? Go ahead and let us know in the chat box. We can help you out there. Just communicate with us what is going on with your slides. Remember, we have 29 of us in class, so we should be able to get 29 green checks. 29 green checks. I see one red X. I think Luis is, it says I need X. Okay. Luis, do you have a Google account? You need to have a Google account in order to open these up. You can use any Google account, but you should be able to have it. If you've been working on the projects 1, 2, and 3, then you should have a Google account. If not, Mrs. Larkin just put in right down here the accounts.google.com. So go ahead and click that open. That's right, Antoine. Let's go ahead and just check in with a few people. Again, if we don't hear from you, we're going to go ahead and move you into the check-in room to kind of regroup, and then you're always welcome back, but you just need to make sure you are regrouping. So here we go. Adrian, green check, please. Looking for a green check from Bowen, green check. Harmony, green check. Looking for a green check from Keon. Luis, did you get your, did it open up for you? I'm looking for a green check from, that's about it. Let's go ahead and get those green checks in. Green checks in, excellent. We don't want to leave anybody behind. Alec, I'm looking for a green check from you. You also put perfect, thank you. I just don't want to leave anybody behind because this is new stuff. We do not want to, it's not like it was before. We don't want you to get lost. All righty. And move on. We're going to talk a little bit about our project now.
Beautiful. All right. Yes, Luis, if you have an account and you're already logged in, awesome. When you click on it, it will ask you to make a copy. Click Make Copy, and it will open for you. That's all you need to do. So click the template link and then click Make Copy. Make Copy. All right. So again, make sure you're logged into Google first. If you do need a Google account, I will send that link to you in the chat box. At this point, you should have a Google account already, hopefully, because we have completed 3 projects, all of which have used the Google account. But if you don't have one, again, please make sure that you do. All right, Luis, we will help you after class then, okay? Or actually, Mrs. Sepulveda, do you want to jump into a breakout room with him and go ahead and have him share a screen? Okay, awesome, Stephen. Perfect. Okay. So let's go ahead. Once you open it up and you've clicked make a copy, that will open it for you. You will then type your name onto slide number 3. From there, let's go ahead and explain what the project will be. So you will be hand drawing an artwork. It could be as creative or as simple as makes sense for you, as long as it's school appropriate. The most important part here is it does need 5 colors. Does need 5 colors. You could also include more, but it needs at least 5 colors. It can be anything that is hand done, Jadelyn. So that is an important thing. You can also paint. Drawing, painting is fine. Painting is fine. Anything that can be hand done. Okay, so when we say hand drawn, we just mean done by hand. It cannot be virtual. Sorry, Andres, I'll explain that in a moment. It cannot be virtual. Okay, yeah. All right, so again, if you don't do a lot of artwork, that's totally fine. You can keep it simple. Keep it simple, okay? Yeah, no worries, Antoine. If you can again keep it simple. You can draw anything that you want as long as it is school appropriate. Okay, so again, I'll show you in just a moment, so just wait. All right, I'm getting a lot of questions that I'm going to answer in just a moment, so just wait. Okay, so you will need to take photos of the start, middle, and end of your process. So I apologize if you already have some artwork. You cannot reuse your artwork, so you do need to do a new process. You're going to give me when you first start your picture. Starting does not mean a blank paper. This means like the first few steps that you do to your artwork. So the first few steps. Okay, so not blank. Not blank, okay? You can get started on this whenever. Obviously, you do need to have it done by the end of the unit. So start this now if you want to. Work on it over the weekend. That way you have it all ready, and that'll be awesome. Awesome, Sally. I'm glad you have a great idea. So you'll need the start, you'll need the middle of your process, and then the end of your process, your final project. Every single step does need digital, sorry, does, I did mention you cannot do digital, and I'll explain why in just a moment. So again, just hold on, everyone. Hold those questions for just a moment. Your name must be handwritten on each step before you take the photo. So we do need to see your name physically on the artwork before you take the photo of it. The reason for this is to prevent plagiarism. So that's the two ways we're preventing plagiarism. You need the start, um, not printing, you need to draw it, Antoine. There's no printing involved because it needs to be hand done, okay? So you'll go ahead and you will show me the start, you'll show me the middle, you'll show me the end. All of those have your name on them before you take photos of them. And then the photos will be inserted in the slide number 4, maybe? Slide number 4, yep. Um, I'll show you what we'll be doing on slide number 5 as well. Again, you don't need to start it right now. You can if you want. You do need the drawing by the end of the unit, but you don't have to have things inserted by the end of today. So don't panic. You have time. You have 2 weeks. Okay. Ivana, so we can go ahead and make some alternative arrangements for you. So go ahead and email us right now. So I need you to make sure you email us right now, and we can go ahead and make an alternative arrangement. My email's in the chat box. Okay. Yes, you can do something abstract. That's totally fine. Totally fine. Yeah, yeah. And so we'll be analyzing all the colors in our artwork. That is a part of how this is related to our science. Okay. So you will be also choosing a song. This unit is about art and music. So you'll also be choosing a song. It does need to be school appropriate. It does need to have both voice and instruments. So it needs both voice and instruments because we will be analyzing both in relation to sound waves, transverse waves, longitudinal waves. Okay, and you'll need to provide the requested details on slide number 5. Again, you don't have to worry about this right now. Just make sure it's done by the end of the unit, obviously. And as we begin to analyze, you'll want to have that done. Okay. Yes, your song does need to be school appropriate. If you have a version that is not school appropriate but has a clean version, that's fine. Just please specify the clean version. And then when we ask for your lyric, obviously include the clean version of the lyric. Okay. Today we will be working on slides 7 through 8 in class. So we will each day you'll get a couple new slides, and each day those slides will either be notes that will help you complete the rest of your project, or it will be actual parts of your project. So just know that as we go throughout each day, we'll be adding to our presentation. We are not grading you on artistic ability. Again, it can be as simple as you want. Simplicity is totally fine. I'm totally fine with that. All right, so let me go ahead and show you what this will look like. I'm going to go ahead and pop this up on the board for us. Let me, where is the links? Hold on. I'm going to drop the link in the chat box. That way I can click it again. There we go. All right, so let me go ahead and drop this up here, and I will show you what it looks like on the board. Again, please bear with us. We know it's a new process, so we're just going to try to go through it step by step. Again, in the end, this will mean there is less work for you. We don't have class assignments anymore, so less assignments you have to be doing. And by the end of the unit, if you're coming to class, you should have a completed project. So that's an encouragement, a reason to be coming to class. Okay, so once you are here, okay, you're going to go ahead and click make a copy. So again, as soon as you click on the template link, you will see this screen and you will see the words make a copy. So click make a copy and that will open up your project. It is automatically saved to your Google Drive. So if you go to www.drive.google.com, you will see it there. Okay. Important, more slides will be added every day to our project. Make sure you're coming to class in order to get those new slides. Again, this project is not just 8 slides long. That's just what we have right now because I don't want you to get distracted by other stuff. All right, slide number 3, I mentioned, please make sure your name is written there. All right, so slide number 3, please make sure that your name is written where it says type here. Go ahead, delete that text, and then type your name. Easy peasy. Slide number 4, again, we already talked about this. Your artwork does need to be done by hand. If you have medical restrictions, please let us know and we can make alternative arrangements, okay? Or if you have restrictions, for example, you don't have anything to color with, another reason to just email us right now. Email us right now. Okay, everybody has Google Drive. If you have a Google account, you have a Google Drive. I can get you the website. Okay, you'll find all of your stuff from there that you've done in class so far. Okay, so taking a look here, if you, so hand done, it does need to include at least 5 colors. You're welcome to do more, but no less. Write your name by hand on your artwork before taking your photos to prevent plagiarism. You need a starting, middle, and final photo. Again, starting does not mean blank. Starting means the first few steps. So starting, mid-process, and final product. You'll take a picture, and then once you've taken a picture and put it on your computer, you can click image and upload from your computer. If you need help getting that photo to your computer, let us know. We should have practiced that in the last 3 projects, but if you haven't had a chance to practice that, please let us know. We are happy to help you get your photos to your computers if you're taking photos on your phone like most of you are doing. Slide number 5, you will see eventually throughout this project, we will be inverting our art because light is related to both the colors that you see as well as the inverted colors. Yes, I do know that, Daniel. Please go ahead and email me and we can come up with an alternative. All right, so I totally know that. Not a problem. I know that your mom has offered to help as well, so that's totally fine if your mom helps too. Okay. Just tell me that. Just literally what you wrote. Say project 4, and then literally what you wrote, just so that we can start the conversation. Okay. So for inverting your art, there is a website right here. Again, you don't have to do it today. Obviously, you have a couple weeks to get this done. But what you'll do is you will click on this website, you'll choose your file, your final product, and then you'll click invert at the bottom, and it will give you the inverted photo, which will be the opposite colors. Again, the original and the opposite colors are both related to our concepts of light that we will be walking through this unit. Slide number 3, we mentioned, make sure you include your music. It can be your favorite song as long as it is school appropriate, both lyrics and topic. And it does need to include both voice and instruments. We are the only ones that will look at your artwork, although we might ask permission to share it with people, but obviously we won't share it with people unless you give us permission. So we would love to share your art if you are willing. Yeah, go for it, Sally. So you'll give us the band or artist. If you do a band, please make sure you type the actual names of the vocal artists right here because we will be analyzing the voices of the vocal artists. You do need a song name, obviously. You need to tell me what will be the instruments that are being used. Again, if you have a clean version, make sure you specify that it is the clean version for when Mrs. Sepulveda and I listen to it. Okay, then you're going to go ahead and choose tell me why did you choose that song, and then what is your favorite lyric. All right, so you'll go ahead and put that there. Now today I mentioned we'll be working on 7 and 8 together. All right, I will tell you this again once we get to questions 7 and 8, but what you will be doing when we get to questions to the questions for 7 and 8 is you will be clicking on the edges of these yellow boxes and then dragging them to their correct category. So either mechanical waves, both, or electromagnetic waves. Again, we will tell you when to work on this, but just so that you know, to move these boxes, click on the edge, and then you can just click and hold and drag them around. Click, hold, and drag them around. Okay, and then same thing with question number 8. You'll be clicking and dragging to move these definitions around up to match them with their terms. And then you will be double clicking in these boxes to label this graph. Okay, so again, we will go over that in a few moments. But again, I just want to give us lots of instructions beforehand so we feel comfortable with this new process. All right, let's go ahead and get started. So you can look it up, Andres. So just look up like a video of it, or you can look up just in the actual, just like Google and say, here's my song, what instruments are used in it. We really only need one instrument, but it's nice to have a variety if you can, okay? All right, so let me go ahead. I am going to share with you a video up on the board, and I want you to analyze what is happening during this video. This video is a stadium wave. All right, so if you've ever gotten to participate in a stadium wave, it's pretty fun. So we're going to go ahead and analyze what is happening in this stadium wave. What is each person doing? So let's go ahead and make some observations. It's on the whiteboard. I'll put it in the chat box as well in case it doesn't work on the whiteboard. All right, green checks everybody if you finished watching it. Awesome. Be ready to provide your observations. Green checks, green checks. I don't know. All right, looking good. So, what I want you to tell me is in the chat box, what is each person doing? What is each person doing? All right, I see answers. Awesome, Sally. Awesome, Brisa, Jalen, Lisa. Okay, yeah, if there was lag, the link is in the chat as well. So you can look at it through the chat as well. Awesome. Yeah, it looked so cool, right? So obviously, yes, we see lots of people in the chat box saying the same thing. Yep, they're standing up and then sitting down, all the while kind of throwing their arms up. Perfect. Now, what I want you to think about though is that as this wave was kind of moving around the stadium, imagine you have one person at the start of the wave. Okay, was this individual person right here like running with the wave to make it move? So the wave went around, but did an individual person have to run with the wave to make it move? No, they did not. So that person kind of stayed in their seat, and that's going to be really important to today's lesson. So they stayed in their seat. So again, even though the wave moved, the individuals did not. They just stayed in their spots. Go ahead and give me a rainbow if that analysis makes sense, because that is going to be related to today's lesson. Excellent. All right, let's go ahead and jump into it. So here's the important part to understand. All waves, no matter what type of waves that we're talking about in this unit, their purpose is to transfer energy. So that is a characteristic that is true of all waves, whether mechanical or electromagnetic. They are all transferring energy. Now, the way in which they transfer energy, though, is a little bit different. All right, so let's go ahead and take a look here. So mechanical waves, for example, require a medium, which means that they need matter. They need atoms or molecules or some sort of particles. So atoms, molecules, particles, something to make the wave transfer its energy. So mechanical waves, they need a medium or matter. This could be things like water or air or solids. So that could be liquids like water, gases like air, or even the earth like solid materials. Earthquakes, for example, are mechanical waves. When you think of mechanical, you want to think of physical. Physical, kind of like how mechanics work on physical machines. They're physically working on something. Okay, so in mechanical waves, again, all waves have energy. Mechanical waves, though, transfer it by passing it from particle to particle because, again, they need matter, and matter is, in fact, particles. Now, electromagnetic waves, on the other hand, when you think of electromagnetic waves, I want you to think about sunlight. So think about sunlight. So electromagnetic waves do not require a medium, which means that their energy, again, all waves transfer energy, their energy can actually go through a vacuum, including outer space. So for example, between the sun and Earth, there is no matter. There's no gases in outer space. There's no liquids kind of floating from outer space from the sun to the Earth, all right? There is no matter between us and the sun. So electromagnetic waves or light waves from the sun can actually travel to us without using a medium, which is really, no, space is a vacuum. Vacuum just means that there is no matter in it. Vacuum, not like a Hoover, for example. Light can travel through outer space, which is extremely important because if it couldn't, we would all die. All right, so if sunlight was a mechanical wave, which required matter, it would not be able to get to Earth, and then we would die. So electromagnetic waves, think about sunlight and how sunlight can travel through outer space, which is a vacuum, in order to get to us. That is how it transfers its energy. Give me a star in the chat box if that makes sense. So mechanical waves, think physical. Electromagnetic, think about sunlight and what sunlight can do. Awesome. All right, so let's go ahead and talk a little bit more about mechanical waves themselves. We'll get into electromagnetic waves in a few lessons, but mechanical waves do not move their matter, their atoms, particles, molecules from one place to another. Instead, those particles just kind of go up and down, or they can go back and forth, or they can even go in a circle. So the particles, just like the people in our stadium wave, do not travel with the wave. They stay in their seat. So particles stay in their seat. Most important concept for this part of the lesson. Only the energy is moving. It's kind of like a game of telephone where one particle bumps into the next particle, passes the message on, and then to the next particle, and then to the next particle, and to the next particle. So they're bumping into each other, passing on the energy, but they themselves are not leaving their seats. Okay, let's go ahead and analyze an example of this. So I'm going to go ahead and put this GIF, oops, sorry. Let me put this GIF up on the board. Now take a look at this wave. In this wave, the energy is moving from the left side to the right side of the GIF. However, take a look at the individual orange particles. What are the orange particles doing? Tell me in the chat box, what do you see the orange particles doing? Awesome. Yes, yes, I'm seeing it. All right, give me one. Yeah, you shouldn't have to log in at all. You should actually just be able to download it without ever logging in. Okay,
Yeah, totally access denied.
you saw it on his screen? He screen shared with you? Okay. Um, let's go ahead and I'll download a copy. Yeah, maybe just have him make a new Google account. I don't exactly know. Cool. All right, yeah, so we can see that the orange particles are going in a circle, right? So they are going around and around and around. They are not actually leaving their seat, which should make sense because if you think about a boat on the waves, as the wave passes, the boat just goes up and down, up and down. The boat itself does not move with the wave because then it would be really tough to ever steer your wave. Your boat would just move all over the ocean. All right, so again, this allows you just to make your boat go up and down. All right, so let's go ahead and talk a little bit about our vocabulary here. So we talked about mechanical waves, electromagnetic waves, and both types of waves. Let's go ahead and match up their definitions. You have your whiteboard tools and 20 seconds. Go ahead and match up which one does not require a medium, which one transfers energy, which one requires a medium like air, water, or earth, which one can move through the vacuum like space, which one's also called light waves, and which one is the energy passed from particle to particle. Keep in mind that one of these applies to both waves. What I want you to think about is mechanical means physical. Remember we talked about that. And electromagnetic, we talked about what happens to sunlight between us and the earth. All right, go ahead, get your answers up there. I do see a couple mistakes already, so please don't just copy what's on the board. There are a few mistakes already. Get your answers up there. Go, go, go. Thank you, thank you, thank you. Fix those mistakes that I see up on the board. Here we go. Get your answers up there. All right, give you another 10 seconds. I see Alyssa on the board. I see Regine, Rowan, Sally. I need more participation. There are 32 of you and only 4 people on the board. That's not going to fly. Let's get some more participation. Thank you. I see Andres working. I see Greta working. Lisa working. All right. I see about 3 mistakes up there. Try to fix those mistakes. Try to fix those 3 mistakes up there. Looking good. Awesome. I see Steven working. I see Ivana working. Caitlin on the board. Thank you. Brisa on the board. Looking good. All right, Antoine. If you do need extra help, let us know, and we are happy to work with you after class, or we can also send the recording to you. We're going to work on this one together, though, as well. Okay, so just give us a moment, okay? Perfect. All right, let me go ahead. I'm going to pause the video, and then I'm going to go ahead and shrink these down, or pause the the tools, shrink these down, and let's go over these. We had a couple mistakes, so let's go ahead and fix those mistakes. So mechanical waves, you are correct that they do transfer energy, but they are actually not the only one that transfers energy. We mentioned this several times. All waves transfer energy. So it's actually both types of waves transfer energy, which I do see a couple people were able to fix that. Go ahead, give me a smiley face in the chat box if that makes sense so far. All right, both waves transfer energy. Perfect. All right, so mechanical waves, let's go ahead and see what are their other characteristics then. I'm going to go ahead and grab a different color here. So mechanical waves, they do in fact require a medium like air, water, or earth. And you should have noticed, which we did not, so this is a big mistake, that a medium is made of particles. All right, mediums are made of particles. Okay, so that automatically means that this one right here is also a correct statement. All right, they are made of particles, and so mechanical waves are the only ones that pass their energy from particle to particle. Electromagnetic waves do not need particles. They don't need any matter at all. So let's go ahead and fix those ones right here as well. So taking a look here, electromagnetic waves do not require a medium. That is definitely correct, which therefore means they can travel through a vacuum like space, just like our sun, and they are also called light waves. Again, the sun can travel, energy from the sun can travel to the earth without any matter, without any particles, which is important because there is no matter or particles in outer space. And if it couldn't do that, we would all die because sunlight would never reach us. All right, this is going to be number 7 in your project. I'm going to go ahead and share with you and remind you how you move the boxes for slide number 7. Let me go ahead and share this with you up on the whiteboard. Again, we are on slide number 7 right now. So slide number 7, again, what you're going to do is you're going to go ahead and categorize them. Again, we just went over the answers, and I will show the answers to you again in just a moment. So you have the answers. We are giving you the answers. All right, and these notes will be useful for later on in our project. Okay, so what you're going to go ahead and do is you are going to just click on the edge of one of the boxes, click and hold, and then you can drag it to where it goes. So for example, the one that's also called light waves, remember, that's like sunlight, so that's our electromagnetic waves. The other one, the one where the waves are passed on particle to particle, again, click the edge, click and hold, and then drag that one over. That's mechanical waves. Mechanical waves are physical. They need particles. In the chat box, please give me a lightning bolt if that makes sense, and you're ready for me to go back to the answers so that you can finish this in 45 seconds. Lightning bolts if that makes sense. Again, click the edge, drag and hold. Hold and drag. Click the edge, hold and drag. Excellent. All right, if you need to, you can also take a picture and finish it after class if you need more time than the 45 seconds I'm giving you. 45 seconds, green checks, everybody. If we do not get a green check, we will move you to the check-in room. Again, green checks once you have taken a picture, a screenshot, or you have finished slide number 7. Green checks. All right, I am waiting on about half of my green checks. Again, okay, so Daniel, again, we have the answers on the board, so take a picture of the answers right now and let me know once you've done that. So take a picture or a screenshot and give me a green check, and then I'll show you again in the actual project what it looks like. Yeah, let me know once you've taken your picture, and then I'll show you what it looks like in the project, and you can finish it after class, just because we're almost out of time. Adrian, Angelo, green checks, please. Darius, Harmony, Jose, Keon, Luis, and Moises, green checks, everybody. Oops. Oh, there we go. Sorry. There we go. All right. All right, Daniel. So again, once you have the answers, you're going to go ahead and put those answers up on your slide number 7 for your project. So slide number 7 for your project. All right, all you need to do, the answers are identical to what you saw in our matching problem. Just click on the edge of the box and then drag it over to where it belongs. Again, we gave you the answers already, so just drag them over to where they belong. Does that make a little bit more sense, Daniel? Perfect. All right, looking good, everybody. All right, let's go ahead and move on. If you missed any of that, that will be in the recording.
All right, let's go ahead and take a look at this. Because of time constraints and purposes, I'm just going to go through this brainstorm a little quickly and just kind of look at and listen to what I'm talking about here. So the highest point, when we look at this wavelength here going up and down, what would be my highest point? So my highest point would be at the very, very top of that hill. And so when we look at the lowest point, where do you think my lowest point is going to be? If my highest point's at the very top of the hill, I'm going to look at my lowest point going to be at the bottom of the hill. All right? So there's my lowest point. But here's one thing I want you to observe and I want you to put in the chat box is what do you observe about the size of the hill and the valley? So look at the hill going up and then the valley going down. What do you observe? Are they the same? Are they larger? Are they smaller? Is the hill good? I'm seeing some answers going up in the top. Good. It's consistent. It's the same. Excellent. Yeah, Sally. It's absolutely the same. So the height of the hill is going to be the same as the height or the drop in the valley. So let's go ahead and put some words to this for our vocabulary. We know that the points on the wave are important. And so the first point of what we're going to talk about is at the very top of the hill. We call that the crest. It is at the max upward, what we call upward displacement. Very fancy, but really it's just saying it's at the top of the hill there. That would be the crest. Okay, now the trough is going to be at the very bottom of the valley. It's going to be the lowest point on that wavelength or that wave. So the lowest point is going to be the trough. Think of when a horse drinks out of a trough. It's going to be kind of like in a kind of a basin. So at the very bottom there would be a trough. So yeah, and exactly. If you look at, if you know a crest, the crest of a mountain at the very top of that mountain. So those are two most important parts of crest and trough. Now we're going to talk about amplitude and wavelength.
All right, so let's go ahead and talk really quickly about amplitude. Amplitude is the actual height of the hill. So while crest is the tippy top, the amplitude is the actual distance from the middle to the top. So this is the height of the hill. It can be from rest to crest, meaning the equilibrium to the top, or it could also be identical to rest to trough, so meaning the equilibrium to the bottom, the depth of the valley. All right, now the greater the amplitude, the more energy a wave has. So for example, in the chat box, when an ocean wave comes towards you, which one hurts more, a small ocean wave or a big ocean wave? Think about if you're standing on the beach and you have a wave coming towards you, which one hurts more? Which one knocks you over? Yeah, a big ocean wave. So exactly. So big ocean waves hurt more. And the reason is because they have more energy, which is evidenced by the fact that they're taller. Okay, now wavelength literally has the word length in it, and you'll notice the word length is also in the definition. So if you hear wavelength, please think length. So wavelength is the length of just one wave cycle. So the way that we find a one wave cycle is we find where it repeats, and where it repeats is where you go from one identical point to another identical point. So for example, you can go from this crest to this crest, and that will be an identical point to an identical point. You could also do it from trough to trough, also identical points, or even on the equilibrium. If you see here where we're going down through the equilibrium and we keep on moving until we're going down through the equilibrium again, that is also a wave length. All right, go ahead in the chat box, give me a thumbs up if that makes sense. Amplitude is height and wavelength is length. It says it in the word. Awesome. All right, go ahead and match these up for me on the board. I'll only give you a few moments to do that because we are moving into passing period. Your next class doesn't start until 11:30, so please stick with us. You will get your attendance in just a few moments. Go ahead and match these up on the board. Which one is amplitude? Which one is crest, trough, and wavelength? Remember that crest and trough are actual points. These ones are points. Amplitude is an actual, and wavelength are actual distances. Perfect. All right, let me go ahead and pause those tools, and I would totally agree with these answers that I'm seeing up here. Great job on those. Let me go ahead and confirm. Oh my gosh, if I can highlight this. Let me go ahead and confirm here. All right, so let's take a look here. So amplitude again is the height from rest to crest or rest to trough. The crest is just the highest point. The trough is the lowest point. And then the wavelength is in fact the length. It has the word length in it from crest to crest or trough to trough. You just need to double click it, Antoine. All right, so this is going to be slide number 8, the top. Let me go ahead and show you what that looks like. All right, and I will go back to the answers in just a moment. All right, so for slide number 8 at the top, what you're going to do is you're going to go ahead, click, hold, and drag the yellow boxes to their correct terms. So for example, amplitude, we said, is height from rest to crest or rest to trough. So drag that over. Same thing, find which one's the highest point on the wave, which one is the length, and which one is the lowest point. Drag those over. Again, to drag, click on the edge, hold, and move it over. Now, I will be telling you to do this bottom part on your own in just a moment. In order to type where it says type here, double click on the box. Double click on the box, and that will allow you to type in there. Yeah, don't click on it while you're dragging. So for these ones where it says type here, you just double click on them. You don't need to move these ones. These ones are already where they're supposed to be. The only ones you're dragging are the yellow boxes, okay? If you need to, please take a picture because we are almost out of time. So I'm gonna go ahead and give you 20 seconds to work on this. Give me a green check once you have dragged them or once you have taken a picture. And then again, I'll give you a couple more seconds on the next slide to do the individual portion. 15 seconds, green checks. Beautiful. Just waiting on about half of my green checks. Regine, Rowan, Stephen, green checks, please. Moises, Matthew, Kalia. Again, if you need to take a picture and finish it after class, that's totally fine. I know we're moving kind of fast. Jose, Daniel, and Alec, green checks. Take a picture if you need to, and it will also be in the recording. No worries, Regine. No worries, Stephen. Looking good. All right, so for this last part, the bottom of slide number 8, this one you do need to be able to complete on your own. You have the definitions, so you should be able to do this just fine. Remember, the amplitude and the wavelength are actual distances. So these ones are distances. So you'll see the distances represented by lines down here. And then the crest and trough are points. So you'll see those represented by dots. All right, so that should allow you to do the bottom of slide number 8. Again, I'll show that to you up on the whiteboard. One more time in case you didn't hear it on the last slide. In order to click where it says type here, just double click on the box. All right, so go here and then double click on the box if you need to, and that should allow you to open it up. Okay, so right in the center, click on it, and then you can go ahead and type them. Which one's the amplitude, the crest, the trough, the wavelength? You already have the definitions. You should be able to do this one pretty well on your own. This is to see what you are learning. I am sorry. Okay, let me share this up on the board. Why is it all black? Okay, hold on. All right, so again, let me show it to you like this. All right, so we can see move this over, right? So the highest point on a wave, click and drag that over, that's the crest. And then to identify the crest, that's the highest point right here. So I would double click on this and then type crest. All right, that's all you need to do for this one. All right, go ahead and give me a thumbs up in the chat box if that makes sense. Thumbs up if that makes sense. Perfect. All right, everybody. So I'm so sorry. I know that we are running short on time. Make sure you get that one done. But what we're going to go ahead and do is your attendance. All right, so for your attendance, all you need to do is click on the attendance link in the chat box, click start a new thread, and then the answer is on slide 7. Based on slide 7 of your Unit 4 project, what is one property of a mechanical wave? This is something that you already did on slide 7, so you already have the answer, and if you've been following along, you should easily be able to get today's attendance. Thank you so much, everyone. Have a wonderful weekend. You have 1 minute to get this done, and then we're going to start logging people out. Bye, everyone. Have a wonderful weekend. Bye.